Hello and welcome to the channel Understanding.Concepts.Of.Physics. So as you can see on the screen, on the topics for the day is amplitude, time period, frequency, wavelength and velocity of wave. So let's just quickly start with all these 5 topics. So why have I started with this topic is the reason is in order to understand waves in a better manner, we should be knowing certain terms and terminologies. So you can just go back to a few videos in case if you are not following things here, because there is a connectivity between the topics. So let's just start. So we are on the terms in wave motion. So the first term is the amplitude. So amplitude is the maximum displacement of a particle from its mean position. So maximum displacement from mean position is called as amplitude. It is denoted by A and the unit is meter because it's a displacement, so its unit is meter, and the dimension will come out to be as L1. Now I have just shown you one wave in front of you. So let's say this is your y-axis and this is your x-axis, and there is a wave which is just going towards the right hand side. Now all the particles are basically vibrating up and down. But this particle, if you see, this particle is vibrating with the maximum amplitude, maximum displacement. This is having maximum displacement, this is having maximum displacement. Now every particle will be having maximum displacement at some point of time, but yes, right now if I say this displacement is the maximum displacement, so that is called as an amplitude. So if it is above the x-axis, it is called as plus A. If it is below the axis, it is called as minus A. In case if you haven't followed my oscillation series, I would request you to go ahead, and I have explained you these things in pretty detail. So this is the first term which you should be knowing when we are studying about waves. The second term is in wave motion is something called as time period. And time period is a term which is very generic, and you will be understanding this time period. We will be coming across this time period at many different places. So time needed for one complete oscillation. So one complete oscillation, the time needed for one complete oscillation, or you can also say for one wave, one single wave, is called as the time period. So if you see this diagram, here a wave starts and here this one wave ends, and again the another wave starts and another wave ends over here. So the time required for this complete wave is what is called as a time period. That's why I have written as a capital T. And another wave will come in double the time period, another wave will come in the triple the time period, 3t, and so on and so forth. It is generally denoted by T, capital T, and the formula for them is omega is equal to 2 pi by T, or you can just invert this places T here and omega here, so you get T is equal to 2 pi by omega. Also T is equal to the reciprocal of frequency. These things, this formula we have discussed in oscillation. I would request, in case if you have any doubts in this, kindly go to my oscillation series and you can just find it. Because it's a time, so unit would be second and the dimension would be t1. So this is what it is. Now the third term for today is frequency. Frequency is the number of waves in a unit time. Now many people get confused with time period and frequency. Time period is basically the time for one complete oscillation, time needed for one complete oscillation. It is the time for which one wave occurs. But frequency is, okay, in a unit time how many waves occur. So if there are 10 waves in a unit time, then we say that the frequency is 10. So the number of waves in a unit time means either it could be 1 second, 1 minute, 1 hour, one week, or whatever it is, okay, but it should be one. Unit means one. That's what is called as frequency. And now frequency is denoted by F, or it is denoted by N, or it is also denoted by nu. Now mind you, my V is always like this, but this is something which is a Greek character which is written like this, and it is called as nu, okay. And the formula for frequency is F is equal to 1 upon time period. This is the reciprocal of time period, and omega is equal to 2 pi F. Again, these two things we have discussed. Unit is hertz and the dimension is t minus 1. So t minus 1 becomes the dimensions for frequency. Then the fourth term for today is the wavelength. the distance between 2 points which differ by a phase of 2 pi radians is called as the wavelength. So it is basically a distance. It is distance, and that distance is between 2 points which are differing by a phase of 2 pi radians, and this distance is called as the wavelength. Now what is this? Now I have just recreated a wave here. This is my y-axis and this is my x-axis, but on x-axis I have plotted phase. So there is a phase plotted on the x-axis. Again, there is a reason why wave motion is always taken after oscillation, and the reason is this: because all this concept of waves and how wave is formed because of oscillation is being done in oscillation. So I would request you again and again to go back and check all oscillation, or maybe if you have prepared it, then that's fine. So I have plotted the wave on the phase. This is a 0 phase, this is pi by 2, this is pi, this is 3 pi by 2, 2 pi, and so on and so forth. In order to get a better or easier way of doing it, remember that starting is 0, and where one wave ends, the phase is 2 pi. And the half of that, that is the center of that, will be half of 2 pi, that would be pi. And the half of that, half of pi, is pi by 2. So if you see 0, pi by 2, pi, 3 pi by 2, 2 pi, 5 pi by 2, these are just basically like values which are very much multiples of one another. So I can say this is 0 pi by 2, which is 0. This is 1 pi by 2. This is 2 pi by 2, which is landing up to 2. This is 3 pi by 2. This is 4 pi by 2. 4 pi by 2 is nothing but 2 pi. This is 5 pi by 2, 6 pi by 2. So if I go in conjugation, it will be 0 pi by 2, 1 pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2, 5 pi by 2, 6 pi by 2, 7 pi by 2, and so forth. So if you subtract the two phases such that the difference comes out to be 2 pi radians, then that distance is what is called as a wavelength. So if I subtract 5 pi by 2 from pi by 2, so 5 pi by 2 minus 5 pi by 2 minus pi by 2 will give me 4 pi by 2, which will give me 2 pi. So wherever the phase difference is 2 pi, we say that the distance is called as wavelength, that is written by a Greek character called as lambda. Okay, now you can take any 2 points here and you can do it. So like say I take 7 pi by 2 and I take 3 pi by 2. So 7 pi by 2 minus of 3 pi by 2, I'll get as 4 pi by 2, which is equal to 2 pi. Again, this distance will also called as lambda. So there are people who also define it like this: the distance from a crest to another crest is what is called as a wavelength. That is also true. And the distance between a draw and a draw is also called as wavelength. That is also true. But yes, it is not only sticking to crest and draws. I can take this point and I can take this point. These two red laser points will also have the distance between them as called as wavelength, lambda. So that's what I have written, denoted by lambda, and because it's a distance, its unit is meter and the dimension is L1. And finally, we come to the last topic for the day, and that is velocity of a wave. So the distance traveled by a wave in a second, that is in a unit time, So the distance traveled by the wave in a second is called as the velocity of a wave. So I am using a basic formula of speed is equal to distance upon time, because things are always in a straight line. Waves are always progressive wave always travel in a straight line. So speed and velocity will not have much difference, and distance is t and time is 1 second. So if you can see, I have sent a second. A second means there is a denominator, you have 1. So the velocity is nothing but the distance traveled by the wave in a unit time or a second. So distance traveled by a wave in a second is called as velocity of a wave. Now thing doesn't end over here. We'll have to derive a very special formula here. So I'm assuming that, let's say, okay, when my time is equal to capital T, let's say my time is equal to capital T, very special time, that is the time period. Now when a wave is traveling a distance of where is it? This one. So when a wave is traveling in time t, that is equal to time period, the distance is what is called as lambda. So in time t, capital T, the distance traveled is lambda. So my equation changes to like this. So when t is equal to capital T, distance traveled is lambda. So in place of speed is equal to distance upon time, I am writing as distance upon time in place, that is lambda upon capital T. Now we know that k1 upon t is nothing but frequency, and frequency is written by n as well. So I am writing n and this is lambda. This is a very important relation which will be utilizing in many different places. So v is equal to n lambda, where v is the velocity of the wave, n is the frequency, and lambda is the wavelength. Also you should note that when we are talking, when we'll be dealing with light waves, we'll be using instead of v we'll be using c, because light's velocity is very special. Nothing can move faster than light. So velocity of light is in c, and in concept of lights we generally use frequency as nu and lambda remains lambda. So c is equal to nu lambda is a very common equation in theory of light. Also we should be noting that this is the wave velocity, this is wave velocity. But sometimes the question comes when particle velocity is asked. So you should note this point that particle velocity comes out to be v is equal to plus minus omega root of a square minus x square. Now if you are finding this is something odd, or you have not studied about this, that means you have not touched oscillation as of yet. Now why is this something different? Because when a wave goes ahead, let's say when a wave goes ahead, when the wave is going ahead, something like this, when a wave is going ahead, the particle is basically oscillating up and down. It is not moving ahead, it is just oscillating. That means particle oscillate, and when particle oscillates, the velocity is equal to the omega root of a square minus x square. This is the velocity of an oscillating body. That's the reason I have mentioned here itself, whenever in the question you have wave velocity, use v is equal to n lambda, and whenever it is for particle velocity, you should be using this formula. Also note that this formula is applicable to transverse or longitudinal waves both. It's a general formula. Lastly, unit of velocity is meter per second, and the dimension is L1t minus 1. So in case if you are still with me, thank you so much for being with me and listening to the lecture. Thank you so much. Have a nice day. Subscribe to the channel in case you have not done so. I hope you liked it. Thanks. Bye.